All right. Okay, guys. I would pull it up on your Chromebook. It's the same assignment. That way, if you don't see the words here, you can put them up on your screen. This is number 1. Okay. Before I do number 1, I want to talk about angle. Let me go down here and explain that. Angle of elevation and then angle of depression. Okay. Because it has this in this word. So let's talk about the angle of elevation. Versus angle of depression. Okay, so angle of depression means that you're looking from a flat plane, like you're looking from the top to bottom. So, for example, if I say I'm looking down on something at an angle of depression, like if I'm looking at a coin on the floor, I would say I'm looking at this coin at a 38 degrees angle of depression. That would be this. Okay. So because you're going down from the top. Okay. So this one is the depression. Okay. That's the angle of depression. Angle of elevation, as you could probably figure that out, is when you're looking up. So if I saw a plane, I would say I'm seeing that plane at an angle of elevation of 24 degrees or something like that. So from the floor or from my eye level, looking up, I'm looking up, that's an angle, whatever that angle is, of elevation. All right, we don't use those words all the time, so that's why it's good to know. So the angle of depression, you're looking down. Angle of elevation, you're looking up. Okay, and it has both of these in this word problem, so that's why I wanted to address those two with you. Any question on these two? Okay, so let's look now. Okay, a lot of words, but it's easy. We have a drone. Okay, so here's a drone. Drone obviously has to be above, right? Because it's flying. It spots the cafeteria west of the campus. Okay, so you do have to know your coordinates: north, south, east, west, right? West is left, east is to the right, south is bottom, north is top. So the cafeteria has to be below, right? Because the drone is up higher. So the cafeteria is west, so to the left of the drone, west to the left. This is the cafeteria. Cafeteria, okay. And then here's the angle of depression. So from the drone, okay, from the drone's perspective, right, looking down, right, so you're looking down at the cafeteria, okay, that's the angle of depression because you're looking down. So right here. Right, so that angle is 27 degrees. Any question right now, guys, with that? Does that make sense so far? Okay. And then we have a sports complex that's to the east. Okay, if you read that, it's to the east of it. So east of the drone. Okay, so to the right of the drone, we have a sports complex. And students are standing there and they see the drone. With the angle of elevation from the eyesight, they're looking up, right? So they see the drone up here. So from the floors or from their eyesight's perspective, that's the angle of elevation right there, because they're looking up, right? So that angle is 34. You guys okay with that angle of elevation, angle of depression? Okay. That's the only part that I thought might have got you. And then they say they're 2.3 miles. The cafeteria and the sport is 2.3 miles apart. Okay. Now I want to switch the question a little bit because they asked for the height. Okay. But instead, just to ease our way into these, let's look for this distance. Okay. So we're going to look how far are the students from the sport complex away from the drone. Okay. Okay, so the first thing, and this goes to geometry. Anybody know what this measurement is? Do y'all remember from geometry of that angle? Okay, it's kind of one of those rules. So if this is parallel, and these are both parallel, if this is 27, then this is also 27. Okay. Okay, so now here's a really important part for us, okay, that you identify what you have to work with. Okay, so if you're absent for this, this is really important. You can go from left to right or from right to left. It doesn't matter, but just start with the edge one. So I have an angle, a side, and an angle. You see that? Or even if you go from the right to left, you have an angle, side, angle. Okay, so this is a ASA problem, which means, if you look there, right, ASA is law of sines. You guys see that? Okay, so I have to do this problem at first with law of sines. That's how you pick what formula you start with. Does that make sense, guys? Because that's really important. Okay. Okay, now for law of sines, remember we had to have the angle and the side, right? I don't have any angle and side. But can I figure this out?
Yeah.
Yeah, right, it's really easy. We had the two angles, subtract it from 180. Can somebody do that real quick? 119. Okay. Easy fix. Now I have the angle and the side, right? So I'm going to use, and I know this is getting really sloppy, really messy here, but I'm going to use this because that's the angle, the side that goes together. And then I'm going to use those two to find x. Okay. And I'm sorry it's so messy, but I'm going to have to write it little before I scoot up. So I have sine of 119 over 2.3. Right, that's the fraction I know the angle and the side is equal to sine of 27 over x, which is what I want. Any questions so far, guys? Mm-hmm. Okay, now is this solving? You've solved a lot of these. So for this kind, you flip, right, because you want the unknown on the top. So 2.3, both fractions, you have to flip both fractions. X sine 27. I need the x by itself, so I multiply both sides by sine 27. Please ask if you're lost or if something doesn't make sense. Okay. Just make sure your calculator is in degree mode because we're working with degrees. So therefore, that distance from the sports complex to the drone is what, guys? Round to the nearest tenth. 1.2, and we're talking about miles, which is... Other, can we get some more confirmations on the 1.2? Yes? Okay, good. Check your answers for reasonableness. Does it make sense based on this that this is 1.2? Yeah, because this is 2.3. So it makes perfect sense. Okay? All right, any questions on this problem?
Yes, sir.
All right, let's do number 2. Okay. Number 2. Before we do number 2, I want to talk about these bearings. How do you do those? Okay, north. So let's go down here and I'll show you how to do those because they're tricky. So, what can we do? How to do bearing? How to? What does this mean? Like if I do north 40 degrees east, what in the world does that mean? Okay, so let me show you. So that means you start from the north end, okay, from the north, and then you go 40 degrees east. So east is to the right, so 40 degrees. It's pretty simple, right? Let's try this one. Do south 30 degrees west. What does that mean? Okay, just try to draw it, see if you understand. Once you do a couple, they're really simple. They're called bearings. Okay, so here's what it is. South is from the bottom, right? South is from the bottom. So from the bottom, you go west. West is to the left. Left, 30 degrees. Okay, so north, you start from the top. South, you start from the bottom. And then you just go either east or west. East is right, west is left. Is that okay? Okay, not bad. Okay, so now you know how to do that. So let's go back to this. All right, so we have two towers, Tower A, Tower B, and they both spot a fire. Okay. Notice Tower A. Okay, so let's do Tower A. So here's Tower A. Okay. They spot a fire. That's north 38 west. Okay, so here's my north, right? West to the left, right? So left of this, right, is 38 degrees. So the fire is right here, fire. Which is really good we're getting this rain, because I was listening to this weather guy last night was saying that if the fires that would catch today, they wouldn't be able to stop them with the winds, that 70 mile per hour wind. So it's good that we're getting the moisture. Okay, and then Tower B is, they spot the fire east, right? So the Tower B has to be over here because they see the fire to the right, east of it, right? So still north. So there's my north plane. From the north, I go east to the right, 48 degrees. 48 degrees. And they see the fire there. And then they tell us the distance from both of these towers is 729 meters. And they want to know how far is each tower from the fire. Okay, so let's go label here. I'm going to call my fire C because these are already A and B. And so that means this would be side C, this would be side A, and this would be side B. So they're looking for side A and side B. Right, so I want to know what is side A, what is side B. Is everybody good so far? Okay. The only little catch here, okay, is, well, I don't have no angles on the inside, okay, of my triangle. But remember, this is going from the north, right? And this is my floor. So what kind of angle is this? 90 degrees. That's right, because you're going from a perfectly standing up to the floor, so 90 degrees. So if I know that's 90 degrees, this is 48 degrees, then this has to be 42 degrees. You just subtract it from 90 degrees. Okay. Again, this is 90 degrees because you're going from the floor to a perfectly standing up plane, right? So that's also 90 degrees. So 90 degrees minus 38 would be 52. Remember what I told you at the beginning? These were the two that are a little harder, okay? But that's how it works. Does that make sense, guys? Okay, once you see it, then you know how it works. So before, don't answer out loud, think to yourself real quick, what is this? Is this a SSA, ASA, SSSS? That's the key part for you, that you understand what it is. Okay, what is it? Angle, side angle, okay? Here's why, if you don't know how to do that. So angle, side, angle. Just go in order. Angle, side angle. Okay, so this is a angle, side angle. Who do we use if it's a ASA? Sine, law of sines again. Okay. I wish I would have done one cosine, one sines, but that's how they set up. So this is law of sines. Okay. I need, again, the side and the angle. I don't have none, but can we figure this out? Mm-hmm. Absolutely, right? Because they have to add up to 180. So what is that one? Huh? 86? Now I have my complete fraction, right? So sine 86 over 729. That's my ones that go together. Okay. And then, well, it just depends. Do I want to find A or B first? It doesn't matter. Okay, let's find A first. So A goes with 52, right? Sine 52. So sine 52 over side A. And then it's the exact same procedure as the last one. You flip the fractions, and then you multiply both sides by sine 52. So it should end up looking like this. 729 times sine 52 over sine 86. What are you guys getting on that one? 187.1. 187.1? Okay. Confirmations? That what you guys are getting more confirmations? Give you a second. No, Camille?
No.
No? What are you getting?
Because I did 575.86.
575.9. Okay, what's different, Alexis?
I didn't do the top.
Oh, okay, good. Good, no problema. 575 look good to you guys? Yes? Okay, and then angle B, the only difference is the angle, so you don't have to go rewrite everything, right? Instead of dividing by, or instead of this being 52, you're going to do 42, because it's the B one. This fraction stays the same, right? You're just changing the B angle. So just change the 52 for 42, and that will give you B. 489 miles, right? We're talking meters, or I think meters. It's meters. Does that look good, guys? To you guys? 482. Yes. I see some head shaking. Okay. There it is. Okay. So, any question right now for you that you have? No. All right. We'll stop here then.